Cool. Hey everyone, I'm Kenny. As mentioned, I'm CEO of a local Seattle startup, early stage startup. Today I'm really excited to be here. I come from the world of AI normally, but I very much feel like you all are my people. We'll get into a little bit of why. So what I want to talk about today is, here's where I started. About a little over a year ago, I wanted to train the world's best JavaScript generating AI model. And that's actually not what this talk is about. But if you go to a model and you say, hey, reverse a linked list, it's probably going to spit out Python. But there's obviously a lot of cool things that it could do with JavaScript, and I want it to be in a certain form. I want it to generate React components that I would be able to just embed. And so I wanted to train a model. And the first thing you do, historically in good data science, is go find data and look at your data. And this has fallen a little bit by the wayside, I would argue. Historically, that's the first thing you would do. But now data sets have gotten so large, they're mostly huge walls of text, whether it's web scrapes or code dumps from GitHub or chat logs from OpenAI. But so I wanted to go see what was out there, and so I went to the single place that has the most open data sets, which is Hugging Face. Love Hugging Face. And I started looking at data sets, and I saw something kind of like this. But I wanted to go deeper. I didn't want to just look at the first couple rows. I wanted to look at more of the data. And they have an embedded viewer, so you can look somewhat at your data. And I started clicking. It's a paginated table, and so I started clicking through. And what I got was this spinner. Now, it's not that long of a wait, but this is where I feel like, as front-end people, you can appreciate this, right? There's all these metrics, time to first paint, time to first interactivity. So what I'm really interested in, and this whole talk is basically about my obsession with the time to first data. How fast can we go from opening a web page to actually seeing the data that you're trying to look at? And I was not very impressed with the tools that were out there. And I'll argue that it's a little bit the fault of Python. The whole world of AI is so enmeshed in Python. And don't get me wrong, if I was training, of course I would use Python. But if you want to build an interface for working with data or anything, really, Python's kind of the worst language you could pick, right? It really doesn't have any good way to build a UI. It's one of the least async languages that's out there. If you want to build something, first of all, no one's installing native apps. So if you want a compelling interface, it's got to be in the browser. So it's got to be JavaScript. So how do you make it better? Why are all the data tools that I see out there so slow and painful to use like that? Now, I don't know any of the behind the scenes of how Hugging Face is architected, but I imagine it looks something like this. Because I've built this kind of stack, right? At my first startup, I was the engineering, architecting the whole system, and this is a very traditional architecture that you might build. There's a front end, there's a back end, there's a relational database, there's metrics, there's logging, all these sorts of things, and it's very complex. And there's a lot of things, it means you have a back-end team that's often, producing things, and then saying, hey, we built an API, throw it over the wall of the front end. The coordination problem is hard, and it's a lot to maintain, right? We had to deploy this onto people's VPCs at one point, and you can imagine how hard it is going into a bank and deploying, they have to do security checks on the front end, the back end. Kubernetes, friggin' Kubernetes is a nightmare. So, look, I don't think it's hard to convince engineers that simplicity is better. So if we just went through this, in the spirit of the best part is no part, what could we delete? If we just took a marker and just deleted things from this diagram, could we delete all these things? Could we delete the back end, the logging, the infrastructure, the database, all that, the Kubernetes? I think so. It's not without compromise, and it's not without effort, but I think we can do this. So if there's one takeaway from this talk, it's this. Burn the back end. So here's what we aspire to. Now, there's one extra box here, right? We like simplicity. Everybody likes simplicity. So why did I keep that CloudFront box there? Well, because it's not just simplicity we care about. It's performance. It's speed. It's the time to first data. And so the fact of the matter is, CloudFront actually just makes things go faster, right? CDNs make things go faster. The world is big. There's a physical reality of, the round trip time. So if you can put the endpoint closer to the users, HTTPS handshakes, things like that, go much faster. Okay, so we're keeping the CDN, but otherwise this is as simple as we can possibly get, right? This is our goal. So before I dive into how we do that, a little bit of sort of a proof point of why I think that there's some interesting sort of data architecture choices that you can make and the benefits that you can have. So OpenAI was the first one that had this product called Code Interpreter, where a model could write code, Python code, they would ship it off to probably a Docker container or a VM, it'll run the Python code to say, generate a chart, and in this case, it sends it back as a PNG, which is fine, but it's not interactive, it's slow, if I want to tweak this, like, I can't mouse over it. Whereas Anthropic went a different direction. They embraced JavaScript. So if you ask Claude to generate a chart, it'll generate a bunch of JavaScript code, and it'll run it in the browser. And so this is more interactive, there's a mouse hover on it, things like that. But also, just think about this from the point of view of people building it, right? OpenAI has to have a team that's on call 24/7, supervising these Python containers that they're spinning up and down. They have to pay for a fleet of servers, and it's all this complexity. And Anthropic was just like, no, we're going to push all that cost and infrastructure and sandboxing onto the user. And that seems like a pretty nice choice. But if you tell this to a founding engineer who's architecting a system, they'd be like, okay, that's great. We love simplicity, but there's a reason why people build systems the way they do. How do we do the things that we need to do without a backend? And there's a whole bunch of things that obviously is use case dependent, but how do you do auth? How do you have how do you store state? How do you run computationally intensive jobs? Things like that. And at a number of the talks at this conference, there have been people talking about you can use OAuth, and you can do that on a GitHub page even. You don't necessarily need a server. Google needs a server, but you don't necessarily need a server, so you can do auth. There's all sorts of browser APIs, local storage, but there's limited space there. If you run out of storage in local storage, you can use IndexedDB and other things like that. You can use web workers to do computationally intensive tasks without lagging the UI. So plenty of interesting stuff there, but I want to talk about maybe kind of a different angle that people don't think about as much of how you build these kind of front-end-first apps. Things like using S3 object storage as sort of just a base layer. Is that a server? Technically, but it's Amazon's problem, and it's so ubiquitous and so scalable that it barely counts. And then if you use some of the sort of modern browser APIs, things like HTTP range GET requests, cross-origin requests, and something that I'll talk about more, which is these cloud-native data formats, you can do some really cool things in the browser. So before we dive into that, there's this philosophy in sort of front-end development called local-first apps, which I think is really cool. But I do want to say I think it's a little bit of an overloaded term, because if you say local-first apps, that can mean different things to different people, right? It can mean something with a sync engine, like Gmail, where if you go on a flight and you lose internet, you can work on stuff, and when it gets internet, it'll resync it with the server. This is cool, but not what I'm talking about. It still requires a server, and if anything, it's far more complex to build a system like that, not simpler. There's also a very sort of privacy-minded aspect of local-first apps, where, hey, we don't want to send our data off to the cloud, we want to run it in a garage server or whatever, which is also cool. They're building cool tech, but privacy is also not what I care about. I care about speed. And I think that's where it's underappreciated that you can actually make apps faster and more interactive by following this paradigm. Many of you may have used things like Excalidraw, but I'm going to use as sort of an example this project called JSCAD. I'm biased because I've kind of over time become one of the lead developers on this project, but it's pretty cool. I think people here appreciate it. It's CodeCAD, where you write JavaScript code to generate 3D CAD designs, for 3D printing and stuff. It's pretty cool, and it's entirely in the browser. There is no server. We're an open source project. It's literally running off of a GitHub page, because we don't, nobody donates. It's we don't want any infrastructure costs. And similar to Excalidraw, what's cool is you go to the website and you're dropped straight into the app. There's no sign-in, there's no work through a flow, it's just you're straight into the app. You can drop a file from your local disk, it'll put it in the editor, you can edit it, you can update the rendering, and if you hit Control-S, it'll save it back to disk. Which, before I worked on this project, I actually didn't realize was something browsers could do. I thought that would have been a security nightmare. But they'll pop up a dialog and confirm with the user and all that. But once you do that, you can use this like an IDE. It doesn't need, a server or something to access local files. And they use a whole bunch of cool web APIs. And so this was kind of my first introduction to pushing the limits of kind of what you thought a normal, an app could run in the browser could do. So then there's this other thing, which is a recent trend in the data engineering community is what I'll call cloud-native file formats. And so one example of this is cloud-native GeoTIFF. So GeoTIFF files are things for storing like satellite imagery. They can be multi-gigabyte files. What cloud-native GeoTIFF innovated was you could put one of these GeoTIFF files up in S3, and if you want to render a map of it, say, this file contains an index of where each tile is. And so you can use an HTTP range GET request from the browser to fetch just the tiles that you want to render in a map. And so you don't need to fetch the whole multi-gigabyte file, you get just the data that you need using HTTP range GET requests. So this is cool. There's another file format that's kind of in this category, which is Apache Parquet. And you can basically think of Parquet files as a CSV file with compression and that contains its own index. So this has also this cool property that you can throw a Parquet file up in S3, like object storage, and you can query against it almost like it was a database, but without needing a server anywhere. And so there's various tools that do things like this, DuckDB, Data Fusion, like some of these kind of like data engineering backend style tools will do this where you can remotely query against a Parquet file. But why can't we do this in the browser? Like that would be pretty neat if we could do that, right? And so I went looking for an existing way to open Parquet files in the browser. And I was not the first person to think of this. There were some other projects, but they have gone abandoned. And so like this was the one that had the most stars when I started, and it had in big bold letters, current status inactive. If you want to take this over, let us know. But as any good engineer was, rather than picking up a legacy project, I decided to start a new project from scratch. And it was pure JavaScript, no dependencies, entirely from scratch. It's not actually even TypeScript, although I do JS doc to type check it. And I have a full implementation of the Parquet spec in 10 kilobytes min-zip JavaScript. And so this makes it really easy to deploy and stuff like that too. But again, what I was really focused on is this idea of time to first data. So what I did was I ran a benchmark of, there's basically 4 ways out there, there might be more, but this was all I could find. There's 4 ways you could load a Parquet file into the browser. There's Parquet.js that I told you about, kind of abandoned, doesn't work with all the Parquet files. There's Parquet WASM, which is a WASM recompile of the Rust Parquet client. And then there's DuckDB WASM, where people compile DuckDB down to WASM and ship it to the browser. The thing I don't like about these WASM ones, and one of the things that hurts their performance, is you have to load the WASM first. And in the DuckDB case, like the WASM bundle is over 20 megabytes. So you're going to spend a minute downloading a 20 megabyte WASM blob before you even start going out and fetching your data. So they start from way behind the ball on that. And as you can see, so Hyparquet, there's general consensus in the sort of UX world that if you can get the latency under 500 milliseconds, that's very helpful. This is far beyond that. We got it down to 155 milliseconds from from the page loading to getting the first data loaded into the table. So how do we do that? How do you make JavaScript fast? JavaScript doesn't exactly have a reputation for speed, and I actually think that's kind of unfair. Now, look, it's not going to beat Rust in a computationally heavy benchmark, but if you do things right, the JavaScript VM is shockingly performant, and JavaScript's one of the most async and friendly languages for this kind of work that's out there. So the things that I think about when I'm trying to optimize JS performance: 1, avoid network round trips, right? If you have to do an extra network round trip, that's super painful. Almost anything is going to be better than that. Broadly speaking, if you want JavaScript to be fast, avoid memory allocation. It costs time to allocate memory, and then it costs more time to garbage collect it later. So the more you can just avoid copying anything, including these Parquet files, like downloading the byte array buffers and just indexing straight into them with no copy, that's the ideal. There's also some of these browser APIs like typed arrays, which are shockingly faster than native JavaScript arrays because they can optimize things for the types, using web workers to offload the computationally expensive stuff so that it doesn't lag. And then there's WASM. So as I mentioned, there's pros and cons of WASM. I have very mixed feelings about WASM, but I want to make things fast, so I use Chrome DevTools. That's one of the things I love most about JavaScript. We have one of the world's best debugging tools installed on every computer on the planet. It's amazing. So I took a profile of loading a Parquet file, and what I saw was that about 2/3 of the time was spent doing snappy decompression, which is the default compression algorithm for Parquet. And so I was like, okay, if we can't optimize that, it doesn't matter if we optimize anything else. So I started looking to WASM. And as I was saying, though, we want this to be very fast. And so if we have to, the typical way you load WASM is you put it up in a file, the browser makes a request for it and pulls it back. And then it loads it. But I didn't want to do that. And so as I was reading through the docs and, frankly, the Chromium source code, I found this thing, which is that when they first came out with WASM, they allowed you to load synchronously. Now, they realized later that this was a bad idea, because everybody has these huge WASM blobs. But because it's the web and you can never break backwards compatibility, they made this caveat that if your WASM blob is less than 4 kilobytes, we will let you synchronously load it as a base 64 string. And so I worked really hard, basically, to make a tiny C implementation of snappy decompression. And if people have used WASM, like the standard way you build WASM is you use this library called Inscripton, which contains like a C standard library for WASM. But that would have put us over 4 kilobytes. So that was not acceptable. So I even had to do things like rewrite my own mem copy in C so that I would have absolutely no dependencies and the compiled WASM blob was under 4K. But then what you can do is you can have like this loading script, which is you can, if you've ever used Vite or if you've ever used any of the bundlers with WASM, it's kind of a pain, because where do they put the WASM file? How do you host it? There's none of that with this, because it's literally just inline, so this will work with any bundler, and it'll just be part of your JS bundle, so there's no extra round trip. It's kind of a cool little trick if you can pull it off. And this resulted in a huge speed up. The bigger the data, the more the speed up, but this was easily worth it for the added complexity from my point of view to get this kind of speed up. Okay, so now we could parse Parquet files in the browser, but the whole point here is that we want to actually look at the data. And kind of going with the theme, like, it's not that there are not libraries out there. In fact, there's a website on here which has like 50 different JS grid implementations, but instead I built my own with, again, no dependencies. But I really wanted control. I wanted to be able to like do exactly what I wanted. I wanted to be able to load cells asynchronously, like as they come in. Parquet is a column-oriented format, so like a lot of the grids out there will be row-oriented. So you have to wait till the whole row comes in. But what if you have one column that's much larger than the others? I wanted to be able to render this all as quickly as possible. So I built this virtual scroll React stable, and then this was all I needed to basically be able to build the data viewer that I wanted. And so we'll do a live demo of that, hopefully. So if you remember, like, here's a Hugging Face one, Spinner of Death, pretty painful. So you go to Hyperparam, and this is the website, and this is, again, you don't need to sign in, you don't need auth, you don't need to pay anything. You just go on the home page, and it's already a live web app. You could drop a Parquet file locally, or you can drop a URL. And this is not a local file. This is coming from the internet, and almost instant. I'm pretty happy with that. Thank you. And this is not a paginated table, right? So like this is a virtual scroll table, so I can scroll real fast through it. If I want to go, halfway down, I can just jump straight to it, and there you go. So it is not loading the full 400 megabyte file. I couldn't do it that fast in this Wi-Fi. It is, again, reading the index of the Parquet and fetching just the data that it needs. And if I want to actually look at this, large unstructured text data, now I have an interface that I can do this really fast. And look, it's not generally going to be fun looking at data, and that's probably partly why people don't do it much. And so one of my goals is kind of to make it fun, right? In the same way that vibe coding is kind of fun. And like, I don't know if looking at data is ever going to be really fun, but I do know this, that if it's not fast, it's definitely not fun. So that was kind of one of my things there. So this is available. Anybody can use this today. If you've got data sets that you're trying to look at, you just go to Hyperparam, drop it in, and you can take a look. So what's next? What's my goal here? Like, what are we trying to do? Well, so some of you guys may have heard of Apache Iceberg. It's a way that you can use S3 as a giant storage database. Like, it's a kind of a competitor to Snowflake and things like that, but you can run it on your own. And it's built on top of a stack of Parquet files, right? They just kind of upload Parquet deltas into S3 in order to make a database that can evolve and update over time. It's used for things like logging and all that. So since I had a Parquet parser in the browser, I was like, oh, well, how hard could it be to parse Apache Iceberg? And it did take a couple weeks, but I built a parser that can actually read and do some primitive writing to Iceberg tables. And so this is cool because ultimately I want to build data sets, right? I want to look at my data, but then ultimately I want to be able to filter it down to just the data that I care about and remove the bad data and focus on the good data. And so that's one of the things that Iceberg can give you, is that you can evolve these data sets while leaving the heavy gravity of the data sort of in place. But I did meet the founder of one of the founders of Iceberg, and I told him what I was doing. I was like, hey, I'm porting this to JavaScript, which is definitely not something they ever thought about. And you can kind of see from the quote that it was a very warm reception from the data engineering community to bring JavaScript tools to this. And so in general, these are all open source libraries. These are all on GitHub. And I think at a big picture, what I'm trying to do here is, I think JavaScript deserves better data engineering tools. And I think that, especially if you're trying to build data tools, the front end should not be an afterthought. It should be a core part of the architecture that you're designing from the ground up. Way too often, I've seen companies that have a very traditional architecture. They have a 4-to-1 ratio of back-end front-end devs, and the front end is treated as kind of a second-class citizen. And the inevitable results of that is going to be unperformant experiences. It's going to be slow user interfaces. It's going to be like you're limited in what you can do. And so what I hope is that people think about this, like the interface is the only thing the users actually care about. The users don't care how you implemented it on the back end. They just want a good experience. And so I don't understand, and this is kind of my rant, is like why that's considered an afterthought at so many companies. But the big picture here is that I do think that the browser is more capable than a lot of people think. You can make it performant if you design it right and you work hard and engineer it right. And the default assumption that you need a backend might not actually be as valid as you think. And if you can get away with building without a backend, it's simpler. There's no coordination between the front and back end. You have to only implement a feature in one place, right? In order to do anything like look through a table, upload a CSV. You need to implement that in the browser, in the Next.js front end, in the back end, and putting a test 3 and all that. If you can just bring that to one, you can move faster. You can build better experiences for the user. It's a better developer experience. It's cheaper infrastructure-wise if you can get away with it. So these are all win-win-wins. Again, if you can get around the compromises. Then the other takeaway, which hopefully people can take from this, is I think these cloud-native formats are really cool. I kind of wish there were more of them than just like Parquet and GeoTIFF. Maybe if you've heard of some, come let me know. Because I think that this is a really cool way to architect stuff. So if any of this stuff sounds like fun kinds of like deep JavaScript hacking on the browser and pushing the performance, the only promotion I'll say is that my company Hyperparam is hiring to do this kind of heavy JS performance work. But the QR code is not actually, it's not my company, it's not my LinkedIn. It's just to the GitHub for my Hyparquet library, because we are like 10 stars away from being the most starred Parquet parser in the browser. So that's my only ask of the crowd, is that scan that, give a star, and we'll be the most popular Parquet parser in the browser. Yeah, that's it. Thank you.